data analytics. And in the past 3 years, we've started to think how we can use the data that we already have to start getting more value out of this existing data. Previously, we've been using data only for ETLs and reportings. And to explore more of how we can use data, one of the tools we've been using is Azure Machine Learning. And today I will introduce to you a bit on this topic. And we expect just a small introduction about the data science process in general, the machine learning algorithms available, and how these concepts apply to Azure Machine Learning in practice. And we'll see how we can build a first experiment and then consume these machine learning models. And in the next few months, I will build on this webinar today to demonstrate more about Azure Machine Learning, about how we can clean data, optimize machine learning models, look at regression models, clustering models, how we can build recommenders, and so on. So today will be just an introduction. And if at any point in time you need to ask questions, don't hesitate to interrupt me and ask questions. Okay, let's get started. So why all this craze about data? It's all because like today we have all these applications that have been built and that we are continuously building, mobile apps, web apps, and so on. So basically all these apps, they are creating data. And a research by IBM recently says that we are creating about 2.5 exabytes of data a single day. So there's a huge potential in data analytics right now, be it in big data, in IoT, in machine learning, in AI. All these are connected to data. It's all different ways that we can exploit data to do more. And actually, if you read on C Corner just today, yes, I think that, yes, just today, Mahesh shared some article about artificial intelligence would be worth 70.5 trillion by 2030. And there's also a video of Bloomberg which explains about the capabilities of machine learning and AI. And hopefully today I will be able to give you some introduction on the topic, and we'll build on this in the next month. So when we talk about AI, machine learning, it all comes to data science. And there are several formal definitions of the topic, but what they basically mean, it basically means to take the data that we already have, to analyze this data, and to make some predictions on top of this data, right? That's, in some simple words, what data science is about. And today, with the computing power that we have, with the power of the cloud computing, so these techniques are more and more accessible, and it's easier to get started to use such techniques to get more value and make more sense out of our data. So how do we achieve the data science? How do we use data to make predictions and so on? There is one common methodology which is called the CRISP-DM methodology, and I find it very accurate, and it's not something new. This has been written since 1996, but the process has grown and changed a little bit in the years, and it is more or less the same techniques that are being used in the cloud tools today. So what it tells us, this model, first thing is this model is iterative. That is, at each step you can go back further to do some fine-tuning. So the steps inside the CRISP-DM models are, as you see, like business understanding. First, you need to understand what the customer wants and what is the goal that we are trying to achieve. Second, data understanding. Whenever we get the data, we need to do visualization, understand what each columns are and what they mean. Next is preparation. Yeah, that's where I think you would spend most of your time. Preparation is about cleaning the data, removing the duplicated rows, removing the null values. Maybe there are outliers, maybe there are columns that are having a negative impact on your experiment. So in this phase, we're going to clean and prepare the data. Next is the modeling part. This is where we create the predictive model. We apply the machine learning algorithms that we have. And then once we have passed our model to the algorithms, next step is to evaluate it. So there are some techniques to evaluate a model, to verify its accuracy, to see how it's behaving. And at each step, let's see that we see that the accuracy is not good enough. So we can go back. Maybe we did not understand the problem correctly. Maybe the data still has some issues. It still needs to be cleansed. So we go back and change and change and change till we get a good level of accuracy and precision. And the last step is deployment. Deployment is how you consume this model. And it is in this area that I think that there is a more technology is helping us more today in terms of deployment. Because previously, like if you've been using some old tools, it was a bit challenging to consume the model. It was like, okay, you developed this experiment, but now what? How do you expose it to applications and so on? But today with the cloud, this can be done like really, really quick, and you can really easily deploy your predictive models to like millions of people around the world, right? So that's a bit about the data science process in general. Now let's have a look at the different algorithms that exist in machine learning, and then we'll see how these algorithms are available into Azure Machine Learning. So the first category of algorithms is like supervised learning algorithm. This is where you're predicting unknown answers from answers that you already have. That is, let's say you have a data warehouse, like you have 10 years of data already available, and then you take this data and you start to make predictive experiments to see like how we can predict customer behavior, how we can predict like this customer may leave the company, like this employee may want to leave soon. So these are the kind of questions that you can ask using supervised machine learning. So the first algorithm that we have is classification. So let's say classifications is like, let's say you have a lot of fruits, and in these fruits you want to like classify the data into two parts. Let's say, is this an apple or a pear? Or let's say you have a data set which has loan data, credit scoring, and you want to predict whether this customer will be able to pay his loan or not. So that's a yes-no question, so that's an example of a classification. And there are several types of classification now, like two-class classification, yes or no, or multi-class classification is yes, no, or maybe, which has several answers. But as long as it's like classifying something, putting it in a specific category, so that's classification. Next, you have anomaly detection. Anomaly detection is like you have a big data set and you find some data that are a bit abnormal, that are out of the box, have some characteristics which is different from the common set. So this example can be like you have a data set of banking transaction, and from this bank data set of transaction you can identify a fraud, like because this transaction related to a fraud, it may be different from the mass of transaction. It is an anomaly. So that's an anomaly detection. And next is regression. Regression is when you're predicting a mathematical value. Like you want to use the data set of, let's say, market price, and you want to take this data and predict like what will be the market price tomorrow. Or you are taking input from several factors, several other markets, and you use this data to predict the price. You're predicting a numerical value. So yes, apologize that I'm taking all the examples in banking because I'm building machine learning models for banking. I hope that you find this example, it makes sense. The next category is like unsupervised learning. Unsupervised learning is when you want to find unknown answers. Let's say you have a big data set, so you want to run an algorithm on top of that to try to classify or group the data to find trends and patterns inside of this data. So one example of this is like you want to build a recommender solution. Imagine a data set, you have a tons of films inside, and you run this algorithm, and they try to separate or group the films in categories, and then it can tell you, based on your profile, you may want to watch this film. It's something that you find on Amazon, just like they have a tons of products, and they run some algorithm on top of that to separate like the products, and they can tell you like, based on what you are watching, you may want to buy this product. So that's clustering. Clustering takes the data and try to group them together, just like this slide here. So you have a lot of animals, so you can try to like separate them and you can group them. And one popular algorithms of this is called like the k-means clustering. So that was a quick introduction to the basic machine learning concepts. And now let's dive into Azure Machine Learning. Azure Machine Learning is Microsoft cloud platform. It is a Microsoft Machine Learning cloud platform which is available as a service. This means that Microsoft maintains the architecture, maintains it for us, and we just have to go to the platform, we have our algorithms, and we can start building. So the power of Azure Machine Learning is that it already have most of the industry tested algorithms, right? So Microsoft has been doing machine learning for years with Xbox, Bing, and so on. So they're taking these algorithms so that they are already using, they have tested it, packaged it, and made it available for users like us to consume and build machine learning experiment on top of that. And it's fairly easy to use, very accessible. And we'll have a look at this today. And to get started, you can go to studio.azureml.net. Yep, if you go to this link and you click on sign up, you will see 3 options available, and you can use any one of them based on your needs. And for this demo, I'm using the free one, the most popular. It works well, easy to use, easy to get started. Just sign in and you can try whatever I will show you today. So once you register on Azure Machine Learning, it will bring you to an environment like this, where we have several concepts. First, the most important is like the experiment. This is the main tool that you will use. It is where you will bring your data, the machine learning will happen. Next, you have projects. In a project, you can like package several components together. And then you have like web services. Web services is like all the predictive experiment that you have already built and you are deploying it as a web service for applications to consume. So this will be here. You have notebooks. If you have Python notebooks and visualization that you have used from other systems or your on-premises system, so you can upload it here. It is the same concepts. You can use data sets, so whenever you are uploading data or connecting data from other systems, so this one will be here. The train models would be the models that you have already built and that you are consuming. So if you want to delete it or make changes, it's here. And finally, you have like the settings. So easy just to manage users, to manage the gateways, the tokens. So that's here. And for this demo, we should use a public dataset, which is called the German credit scoring dataset. So what's inside this? This is a credit scoring dataset, and it has several columns related to loans of customers. So you will see like loan ID, yearly salary, duration, all this. And finally, you have a column called status. So this is whether the customer has been able to pay his loan or not. So that's here. So what we'll do now, we'll train a model like based on all these features, all these columns, we call it features, and the column that we are trying to predict, we call it a label. So we'll use all these features to train a model so that we'll be able to predict the status. So what we try to do now, we'll try to build an experiment whereby finally we'll build a model and we'll publish it as an API, and then we'll have an application or Excel that whenever there are like new loans, so imagine an account executive of a bank, so he's sitting like in front of a customer and the customer comes to him and tells him, okay, I want a loan, and like, what is your profile, what is your property, what is your name, your age, and so on. So the people will fill in these details, and this application will be able to like give an idea of whether this person will be able to repay his loan or not. So that's like the kind of thing that we can do. So how this can be used really is like, you know, like these persons, account executive, they often have targets. Like each quarter, they need to sell like 1,000 loans. So it's, imagine like it's 2 days to quarter close, and the guy has like 10 applications, and this will take a few times to analyze. And he wants to know which one will he send to the credit department for priority, because he has only 2 days and he can't send everything to the credit department. So he can use a tool like this so that he can get an idea of which one has more chance of being approved, and then he send only the ones that can help him meet his target as priority, and eventually send the other one later. So that's like how powerful such a tool can be. Yes, so, and back to the portal. First thing you want to do is to create an experiment. Right? Actually, I think I have a few more slides. Yes. Sorry for that. I forgot this one. This one is the Azure Machine Learning workflow. You will see that the workflow in Azure ML is more or less same as the CRISP DM models that we saw earlier. So first it tells you to import your data, do some cleansing, pre-processing. Next, that's an important concept, is the split. So what this is doing here, it is splitting the data into 2 datasets, the test dataset and the train dataset. So we shall use the train dataset to expose it to the machine learning algorithms for learning. Then we shall use the test dataset to verify whether the data that has been predicted by the algorithms here, whether this is correct. Because we can't use the same data for training and the same data for testing. Does that make sense? So that's what this split module does. Split it into the train dataset and the test dataset. Then here we expose to the several algorithms that we have inbuilt Azure Machine Learning. In the train model, the learning occurs, and then it evaluates, it checks whether the data has been predicted correctly in the score model. Okay, back to the studio. Yes, so first thing is you would like to import data. So you can click on new data set here, and from local file, if you're importing from a file, and you can browse your file here, and here you have several types of data sets that's compatible. And in this demo, I have already uploaded the credit scoring dataset, which should be here. Under my dataset, yes, that's the dataset I have uploaded. Now I will create a new experiment. So create experiment, and I will start with a blank experiment. Yeah. So I will under datasets here, my dataset, I will see all the files that I have. I can just drag and drop it. So in case you want to connect to some external data source, you can use this here, this import data module. Like if you're connecting to Azure Blob Storage, or you can connect to a web service directly in case like your data is in some other database which is not on Azure. You can use like expose a web service and use this import data here to bring the data to the Learning Studio. You can use Hive, Azure Table, data feed, even an on-premise SQL database. So, yep, in our case, we are using this data set. And you can right-click on it to just visualize the data, how it is. So right here, we can see that we have all the columns like that was in Excel. And just by clicking on the column, we can get some statistics here on the right. Yes. And yes, for all the columns, like if we look at the age columns, we can get some statistics, and we can easily see that we have some missing values, which does not seem right. And we can do this for all columns. Or if you want a faster way to visualize your data, you can use the summarize data module. There it is. It's again drag and drop, very easy to use. So once we have connected these two modules, we can click on run. Okay, so this will run your experiment. And once finished, you can right click on here and click on visualize, and you will see a graphical summary of all the columns in your dataset. So at one glance, you can have some statistics about each of the features of this dataset. So just by looking at it here, we can see like the column age here has some missing values, like where it is missing values, missing value count, you have duration, month, and you have age with some missing value count. So next step that you may want to do is like coming back to the crisp DM model. So the next step that you want to do is to prepare the data. So right now we just visualized it and we saw like we have a few missing columns. And now we'll use the Azure Machine Learning to prepare and cleanse this data. And this will be just a small demo of cleansing, because cleansing has a lot of features and we'll talk more details about it in the next presentation. So we have this module called clean missing data, I think. Yes, here it is. So we can connect it to our source data here, and we click on launch column selector to select which column we want to cleanse. So here we can just select my name, and if I recall it was in the column age, right? So we can click on age, select this column for cleansing, and to your right here you can tell it what do you want to do with this. You want to replace it with a mean, median, mode, or some custom values, or just remove the entire row. Let's remove the entire row. And yep, and run the experiment again. So how much max data can you handle? I'm not sure. So far I've never got issues with this. But in any case, if that's too much for a file, yes, because it might be a bit difficult to upload the file directly here. So you can still connect to the other kind of services, maybe a web service or Hive queries. If you have really big amount of data, you can use like connect to a Hadoop cluster directly, because we have something called Azure Data Factory. Let's say you have a lot of data in a Hadoop cluster. In Azure HD Insight, you can take this data and bring it to Azure Machine Learning. So I will have a look at how much data can you, the maximum file size that you can do. Do you have any Spark connector? I'm not sure about, I did not see a Spark connector. But I know like what you can do if you are using Spark. I'm sure like you are using it like in a Hadoop cluster or HD Insight. So you can connect to a Hadoop cluster using Azure Data Factory to bring the data to Azure Machine Learning. I hope I answered your question. Okay, now that we have cleansed the data, let's have a look at what happened. So now if you look at the column age, where is it? Yeah, if you look at the column age, you won't see any missing values. So just like that, there are a lot of other treatments that you can use to cleanse data. And if you can't find a module to clean data directly, you can still use like custom Python, custom R, and custom SQL scripts to add custom logics to clean and prepare your data. So the next step now is to split the data, because remember, like we said, we're going to have a test data set and a train data set. So we use the split data to do this. The split data, and you connect it, and then you tell it which portion will go to the train data set and which portion will go to the test data set. So we'll let's say that we will allocate 70% for training and 30% for testing. And if you want to add a random seed to randomize the amount of rows that's going to the train and what's going to the test, you can add this here. So once we have our split data, we have the train and test module. So we can now start training this data set. So to do this, we add the train data set, the train module, where is it? Yes, the train module here. And you connect this part of the data, which is the train data set, part of the data set, you add it to connect it to the train module. And for here, you need to connect the algorithms that we have. So as we mentioned earlier, it is a two-class classification. So we can just search for it. So we have a bunch of two-class classification algorithms. Let's say we want to use a two-class decision forest jungle. And if you have more questions regarding the algorithms available in Azure Machine Learning, you can use the cheat sheet. That's I can send you the link later, but there is like a cheat sheet available, and which at one glance you can have a look at the different types of algorithms, and for each type, which algorithms are available in Azure Machine Learning, and for each algorithms, it gives you like in which use case it is mostly used. So in our case, we have a two-class classification, and we have all these two-class classification algorithm, and for each of them, it tells you like this one is for modules which has more than 100 features. This one is for fast training. This one is for high accuracy. So you can use this cheat sheet to get started to go really quick. So in this case, we are using a two-class decision forest. So we connect this to the train model. Next, we need to do scoring. So scoring will compare the result of the train model versus the result of the test data from the split module earlier. So next thing that we need to do is from the train model, we need to specify what column that we are trying to predict. So in our case, we are trying to predict the status column. So you add it here, status, and you can run it. Let's have a look at the questions. Yes, you can add the default values. Yes, you can do it. Yes, I think it's 10 GB free per month. Yes, 10 GB per month. Yes, you can bring your custom Python and R script. Can you have multiple target variables? Maybe I don't understand your question, Ankit. Maybe you want to have several models and then compare the models. Yes, I will show that in a few moments. So let's come back. So our experiment has run. Now, if we visualize it, you will see what outcome we have got from the score model. So let's look at it. So yes, here we have the actual status, because you are building a model based on the known values. And this is what the program, the machine learning has predicted. So it is not always correct, but in the next sessions, I will show you how we can tweak and better prepare data to get more accurate models. This is just like the getting started part. Okay. So again, if you don't want to go again in all the rows to view whether it has predicted correctly or not, you can use the evaluate model. The evaluate model will give you a summary of all this data from the score model, and will also compute some KPIs for us to evaluate this model. Let's have a look at the questions. Can we leave charts? Yes, you can add charts. You can write your own custom charts using R or Python. If you are using like ggplot2, for example, you can write this using R. Or you can also use, there is a tool called modules inside of the, where it is? There's something which is called modules where you can import modules to plot charts. Yes, you can plot charts against this data inside Azure Machine Learning Studio. So now when you look at the evaluate models, so you have some of the KPIs that showing you how the model is behaving. What's important for us now, it is the accuracy. So this model has an accuracy of 0.7, not that bad. And you can also see other KPIs like the true positive, false negative, true positive. And depending on your use case, at one glance you can have a look at what's happening and you will know how you want to predict and improve the prediction results. Let's say in the examples of a loan, I think it's more costly. You need to think, what's more costly for the customers? Is it more costly to predict a good loan as bad, or to predict a bad loan as good? So that's here. To answer these kind of questions, you look at the rate of true positive and the rates of false negative, right? So I think that it's more costly for the customer, that is for the bank, if we predict a bad loan as good. So based on these scenarios, we improved our experiment. So one way of improving the experiment would be like, let's say we want our model to learn more from bad loans. So there are tricks that you can do inside to make it learn, like duplicate the values of the bad loans to make the model learn more from the bad loans. And this will again have an impact on the true positive and false negative here. So, but now let's say that you're not satisfied. You say that 0.762, no, that's not good. We are not satisfied with this algorithm. We want to add another algorithm. Yes, that's possible. So it all starts again from the split data here. So we can add another train model. Add another train model. You add another score model. And you add another algorithm. Let's say we want to use a two-class decision jungle. Right here. And we connect it. Decision jungle. And then we use the test dataset to evaluate the result of the score model. And we also need to determine which column we are trying to predict. So yes, just to give you an overview, there are several ways you can select columns. So first is by names. So you can go into each one of them and click on add, or you can use the rules here. I find this one much quicker. I just say include column names and I just type it here. So I find it much faster. It all depends on you. Add it here, and finally we can connect this score model to the evaluate model here. And one more thing is each of the algorithm, you would find several parameters like how the learning is happening, how many decision trees, how many nodes, how many leaves it's using, and you can configure it to use several kinds of parameters which will make it better, slower, faster, and we'll have a look at all this in the next series. So for now, let's just run the experiment. Ankit is asking, can we lift charts and gain charts on predicted data? Yes, we'll get to that in a few moments. So the model is running. So now it's done, and we can visualize the output here in the evaluate model. So now inside the evaluate model, we'll see like two algorithms, the performance of two. So first was this one, the blue one is the first one we did, so 0.762, and we can click on the second one to see its performance. So this one is a bit lower, like 0.717. So that was just a quick demo of how you can compare the performance of two models. So as we can see, like the two-class decision tree forest was better. So now what we want to do, we want to use this model and package it and publish it as a web service. So what we need to do, we need to select the model that we want to publish. We click on the train model and we click on predictive expert deploy as predictive web service here. So at this stage, Azure Machine Learning will take all the modules, package it, and create a predictive experiment, and define the input and output ports and connect it to the web service. So all this is done just in one click. Again, the power of Azure here, very good stuff. So once this is its package, what we need to do is we need to run the experiment just to test that everything is run, everything has compiled correctly. It's running. Okay, now it's done. And we can visualize the data here. So basically here our output would be as follows. We would see all the columns that has been inputted to the experiment, and we would get the status and the scored labels, the labels that has been predicted. But we don't want all this in the output. It may be a bit difficult to understand. Let's say what we want the web service to return us. We want it to only return the loan ID and the scored labels. So what we do here, we can just add a select column module, a select columns. Yep, here it is, select column in dataset. And we connect it to the output here, and we connect its output to the web service. And here again, we can select which column we want to output. So let's say we want loan ID and status label. Oops. And the label. Code labels, yes, and there's code labels. We want these two columns to be returned, so we can just add it here and we need to run it again. So you will notice that this time it runs faster because Azure Machine Learning already knew like the outcome of this part of the experiment. So when you run an experiment again, it runs only the part that has changed. So that's why it runs faster. Now it will, if we view the output again, so you will see only these two columns. So now we are good and we are ready. We can just deploy our web service. Just click on deploy web service here. And we are good. That's it. Our predictive experiment is now deployed and we can now consume it. So you may want to test the results quickly. So what you can do is like you click on test here. So it will show you all these text boxes where you can input and view the experiments, view the output, sorry. I don't want you to see me typing all this. This will be boring. So let's find some other ways to test this. The second way to test it is to use Excel. So when you download this Excel file, it already have a plugin to connect to Azure Machine Learning. It already have the web service URL, and it already have the API keys configured. So very, very easy to use. Let's open it. You need to enable this here, yes, because it has some plugin. And as you will see to the right hand side, you will see the Azure Machine Learning plugin here. And you can select which experiment you want to test. And another very nice feature is you can use sample data. Just click and it will generate all the set of sample data to test your experiment quickly. So that's the sample data. Right here it is. And now, oops. Okay. So next step is we'll tell it we'll need to define the input data set here. So you click here and you select all the columns in the tables. Okay, that's all the columns. And then we need to tell it where to output the data. Let's say we want to output it as from cell W1, and we click on predict. So it's doing its magic. It's taking all this data and it's sending it to Azure Machine Learning experiment, and it returns the data here. These two columns were not here previously, and here it is. You can find the loan ID. This one is the loan ID that was passed to the experiment. So if we look at it, loan 001, yes, it is this one, and it predicted the value of 1. That's it. And the actual value that this loan, it was 1, so it's predicting it correctly, it's sending it to the API and getting the value back. So that's like in Excel, very useful in case like analysts are using it. So let's say the analyst now want to say like, okay, so what will happen if, let's say this customer's loan, it was for 48 months and no, this guy would not be able to pay. Let's say, what will be the probability this customer will be able to repay his loan if instead of 48 months, we put it to 12 months. So he can just change this value here, and he select the input data again. He just have to select the input data again and define the output and click on predict. Okay, for some reasons it does not want to work. Let's try this. Sorry. For some reasons it does not want to work now. Let's try this again. So data, okay, predict, okay. There it is, and you get the results back. It's as easy as that. Or you can change any features and just click on predict again to see the behavior when you're changing the features. Or if this experiment is not to be consumed by an analyst or someone that is using Excel, you want to consume it in applications, yes, that's equally possible. If you click on request to response here, so it will bring you to a page that will show you all the details of the web service from the post method, if you are using HTTP, and all the sample requests, the headers and so on, the body, all the detailed data of what you need to post to this service in terms of the attributes. It gives you the output parameters, in what format can you expect an output, the output result. Remember, we included only 2 columns, here they are, and like this was not enough, they also included some sample codes. So that's sample code in C#, Python, and R. So if you want to run it in a mobile application or a web app in C#, it's as easy as just copying the code. You paste it here. Oops, it's not working. Select, you copy the code, and you paste it in some programs. Very important, you need to change the API key. The API key is found on the web service portal here. Copy it. You change the API key, and if you run some app, you would write some kind of code to put values here, for like to map the loan ID, the salary, the month, or the features to replace it with actual values. So I already have a bit of this. Okay. And it just works. I don't know what happened. Maybe I missed something here. Let's see. Let's replace the new string table. There it is. Yes, and it just works without too much effort. It just works. So it will create an HTTP client, post the request, add the authentication token, and call the web service, and that's it. It just works. You get the output result back, so you can very easily integrate the experiments deployed on machine web service and consume it in basically any types of device or any types of applications that you want. You can get this started very quickly, very easy to use. So that's it for me. So I think we covered all of the topics. Do I have anything else? Yep, that's it. Well, thank you very much. Do you have any questions? And yes, we will definitely meet in the near future. We will talk about in details how we clean data, how we optimize machine learning experiments, how we can build regression models, clustering, and recommenders. Do you have any questions? That's it from me. Hello?
Hello?
Yes, so I think we are good. Thank you
Yeah,
very
yeah.
much.
Thank you.
Can we determine the significant variables? Yes, you can determine the variables. By variables, I think you mean features. Yes, there are tools inside to allow you to run some kind of algorithms to determine which one of the features are significant and which ones are not. And you can remove them inside of the experiment. So we'll talk more about this in the next webinar when we talk about the data cleansing parts. And can I create an Azure account with debit card? I have no idea on this. I don't think so. But Yadav, you can create a free Azure machine learning account without a debit card. That's true.
Can you just talk about some of the production scenario we can use this?
Sorry?
Can you please talk about some of the production scenario where we can deploy and use this, the example you gave?
Yes, so I've been talking a lot about the banking and credit scenario. So I just gave an example earlier in terms of credit scoring. So let's say you have an account executive like in front of a customer and someone asks him, so what's the probability I can get a loan like tomorrow or something like that. So you can just easily build a web application. Imagine a banking web application like an account executive is using where you already have the account details and someone tells you, okay, I need a loan, 12 months, in the application, you will already know his salary, you will already know his name, his address because he's a customer. So you just need to capture the basic loan details and you click on like submit, you call the web service and it runs the credit scoring predictive experiment and gets you the data back. And you would say, yes, actually, based on your profile, you have a high chance of getting a loan, right?
Yeah, got it. Thanks.
That's a very, I think, easy to explain scenario where you can use it. Or in transactional data, like banks are using it nowadays, where you have millions of transactions happening daily, and at the end of the day, you can just take your data, feed it into a anomaly detection algorithm, and you can identify frauds and so on. Or even in real time, like when imagine a card transaction happening, like I live in Mauritius and I have a certain profile. So if tomorrow I made like transactions up to 1 million every day, that would be an anomaly. And this can be flagged in real time using machine learning and anomaly detection algorithms. That's it. Any other questions? When will be the next session? I don't know. Santa, when will be the next session? I will schedule it via C Corner portal. I think in 3 weeks maybe. Yes. Any other questions? Yep. All right. Bye-bye. Thank you.
Thank you.
Thank you, Chervine.